deal with the toughest part of nervous system. Yeah, okay, you can get front row seats if you want. Okay. How is it recording? Right. Today our focus is on the nervous system, but we just zoom in on the tougher parts. Okay. So first and foremost, just like with every system, like the circulatory system, you need to know the parts. Yeah. Okay. So what would be critical in the nervous system? The parts that you want to focus on are number one. Okay, on a cellular level, you need to know the structure, function. Okay, so there are two levels to this. Number one, the structure and function of nerve cells, or what we call neurons. Yeah, and then you also should know the structure of the eye. Right? The function is what we're going to talk about today, the function of the eye. Let's begin first with structure and function of nerve cells and neurons. Okay, I want to show you that actually the structure and function of the neurons are, once again, whatever I collate over here inside Lumos, right, it is, I'll say it's good enough. Okay? Yeah, I hope our audio is working. I don't know if it's working. I'm just gonna. Okay. Okay, so let's first look at the structure, function of nerve cells. I'm going to show you the structure and function of nerve cells in context to a reflex arc. Okay, a reflex arc. Do you know what a reflex arc is? Have you ever, I mean, you can do it to yourself now, or you get your friend to. Just go and give one knock to your knee, see if it flies up. What, look at mine. When I hit it, right, it's going to fly up. 1, 2, 3. Hi. Okay. That one's not a reflex arc, that one is myself going. Okay, so we're just gonna quickly run through the reflex arc, and then you will very briefly see the kinds of neurons you encounter. Okay, you can try it. Usually it doesn't work if you hit yourself. If someone else hit you, it will be better. You crop that sentence out of context, right? Sounds very bad. Okay, let's watch. Okay. First and foremost, when we look at the nervous system, you want to know that there are two broad parts to your nervous system. Number one is that when we look at your brain and your eyeball, okay, and after that your spinal cord, right? Okay, that is what we call the central nervous system. This is the part where all of the connections are made. Then, very often in the nervous system, you will see things branching out, okay, to different parts of your body. It may go to your arms, it may go to your lungs, your heart, your legs, so on and so forth. And then there are also nerves that go back to the central nervous system. There's like a directionality. Okay, some going back, some bringing signals back, some bringing signals away. Okay. call this the central nervous system where everything is processed. Okay, all of these at the sides, these are like the peripheral nervous system. Okay, they're not part of the central part. Okay, periphery. It's just not so important. I'm just like categorizing them. Okay, so now, okay, right, what's so funny? Oh yeah. Okay. Alright, so okay, but now let's focus on the cells involved. Actually, can you still remember? I feel like it's not that bad. Okay, what are the neurons involved in detecting stimuli? Stimuli is a stimulus from the external environment. You remember the neuron that does that? Okay, so you only know 3 neurons, okay? And then you already know what the structure looks like. Can you remember the name? Okay, so the ones that are detecting stimuli, they are called sensory neurons. Yeah? Okay. Then, after it detects, whatever it needs to detect, it will send electrical impulses to the central nervous system. That is where usually you will find another kind of neuron that is linking and doing all the connections from the sensory eventually to the motor. Okay? Usually we will call this the relay neuron. Relay neuron, you can find it in the central nervous system. That's where everything is processed. Finally, you have your motor neuron. These are neurons that will transmit signals to a lot of the things you find in your body. For example, muscles. Okay? After all, that's how you control your body, through muscles, right? The signals need to be relayed to something that you can control. That is very often your muscles. Here on the screen, in this video, which has no audio, there are many different kinds of things you can detect when I write stimuli. It can range from temperature, over here CO2 in the blood. Okay, but I think temperature may be quite familiar to you. Motor neurons will eventually transmit signals to things that you can bring about change for, like your muscles or glands that produce hormones. For us, your focus would be, can you identify the 3 kinds of neurons? From sensory, relay, motor. Okay, on the screen right now, I'm going to show you a rough diagram of the 3 kinds of neurons you can find. From the red to the blue part to the black part. Okay? So let's have a look at where is sensory? Okay. So expect that if I were to zoom in, this is what you see. Sensory neurons often have a lot of fibers branching out. Then you'll find a long strand of nerve fiber. Often you'll find the cell body somewhere in between. Okay, that is a sensory neuron. After that, you have a relay neuron. Finally, you'll find a motor neuron. Okay. Here, notice I've drawn a simplified drawing of whatever you see up there. So actually, what's the skill here? Can you differentiate the different kinds of neurons based on their rough structure that we've drawn? For example, notice that motor neuron, it has a body at one end Then from that body, you'll find lots of fibers branching out, and then you'll have one long fiber coming out. You look at a sensory neuron, they have fibers running out in both directions. You tend to find the body of the cell somewhere smack in the middle, or somewhere in between. The relay neuron, also you observe the same thing, except that you expect it to be a bit shorter. So the skill you should have over here is that be able to differentiate. If I were to just give you this structure, what would you say? Do you think it's a relay or a motor neuron? If I just give you this, do you think it's a motor, or do you think it's a relay neuron or sensory neuron? The structure. Don't need you to go to the extent of describing the structure, but can you identify the structure? Sorry, Ryan? Right. Does relay neuron have dendron and axon? Have. They do have dendrons and axons. Why? They don't have what? Myelin sheath. I wouldn't say so. A lot of the neurons do have myelin sheath. Okay, so see, all these are a lot of details. Don't need you to know to the extent. All the myelin sheath, all the stuff. Okay? Do you know what I'm talking about? Oh yeah, but now we're at GH4, you go and focus more on your GH4 topics, okay? Okay? We deal more with the toughest part of the topics. So, just in case, okay, so if you really do come across these terms, notice I keep saying the word cell body. The cell body is the main part of the cell where you find the nucleus. Then you'll come across words like dendrons, dendrites, axons. Okay? Over here. For example, dendrons and dendrites. Okay? You ever see the word dendron and dendrites? It is the fibers that are receiving the signals. Okay? So these are, for example, dendrons and dendrites. These are the ones that are receiving the signals. Axons, like away, is the one that's transmitting the signal away. So for example, if you look at this long fiber here, that can be an axon. It's transmitting a signal away. Okay? You don't need to know too much of that. Just know that this differentiate the terms cannot dendron axons. Okay? So to this extent will do. I think it's important you know that there are three kinds of neurons. Right? You will be able to identify the structure of the neurons. Okay, we have every system you need to know the structure. What would be the function of the neurons? An example you can give is like a reflex arc. Know that the signals travel from sensory, the relay, to the motor. It doesn't go the opposite way. Okay? Your muscles don't detect things from the environment and induce change the opposite way. So that's just one part of the nervous system. Knowing the reflex arc, knowing the structure of the nerve cells. That's on a microscopic scale. The next part of today, we're going to look at something bigger, the eyeball. Okay? And that is like the heart of the circulatory system. The eyeball is like the important part of the nervous system. For that, we must first know intimately the structure of the eye. Okay, let's look at this structure of the eye. It's been cut into half. When we look at the structure of the eye, then we can appreciate what it does a little bit better. There are two functions that our eyeballs can do. I think broadly you should know. Number one, when we look at the function of our eye, I should use blue to be the same. The function of the eye, number one, we can adjust the brightness. Right? If it's too bright or too dark, we can adjust the size of, what's that hole called? Okay, can adjust the size of our pupil, right? That hole. Okay, so our eye can change depending on the brightness. It can adjust to brightness. It can also adjust to distance. adjust the brightness, you can adjust the distance. Now, what's more important is, you know which are the structures involved in adjusting the brightness and which one is involved in adjusting the distance. Okay, let's look at the structure of the eyeball over here. Here's the front view. If I look at the side view, this is what you see. You can also find this on Lumos. So if you want to follow me, you can even go to the website now, then you look at the model. Okay, look at the model. If we were to zoom in, you will see that over here, there's a black region called the pupil. Understand that the pupil is not a thing, it's a hole. Can you see each other's pupils? You can. You can look into each other's eyeballs now. You look very carefully, there's a black dot right in the middle. That black dot is a hole, it's not a thing. But what's more important for you is what's surrounding the pupils. You see this this brown portion over here? That's called the iris. Are you looking at each other? Okay, the iris is our muscles. Okay, so that's the thing. When you want to talk about brightness, the part of the eyeball you want to look at is the iris because it's made up of muscles. Okay? There are two kinds of muscles there you want to be aware of. I don't know if you can remember. Number one, in the iris you'll find circular muscles. And you will find radial muscles. Okay, this segment is the part where I think students find a little bit hard to understand. But you all help me understand why it's hard to understand. Okay. When I talk about circular muscles, circular muscles are muscles that are running in a circular motion and they connect end to end. Okay? So if you think about it now, if I have a bunch of circular muscles like that, so this is what you need to understand when we talk about muscles. When muscles contract, they lengthen or shorten. That's an important thing to know. When muscles contract, do they lengthen or shorten? Because this will ground us in understanding later on also. Shorten or lengthen when muscles contract? They shorten. Okay? So when a muscle contracts, it shortens. So if I have circular muscles that contract, will this hole in the middle, the pupil, be smaller or bigger? Must try. Even if mentally you have the answer also good. Smaller, right? Okay, so you must understand that when muscles contract, they become shorter. Okay, that's the first thing. So if the muscles contract, they become shorter, you'll find that the pupil size becomes smaller. Okay, so this is it contracts. Okay, therefore, when it relaxes, when something relaxes, you expect that the fibers become longer. Right? So let me just do it the reverse. Okay, so if it relaxes, the muscle fibers lengthen. Okay. What in the world are radial muscles? Radial muscles are just muscles that run in rather a circular motion. If this is the iris, the radial muscles branch out. They are radial in nature. So for example, over here, I'm going to draw radial muscles. These are radial muscles. The black one. Here are radial muscles. Yes, Yichuan. Anything? You want to clarify? Okay. So again, remember, muscles, when they contract, they become shorter. How will you describe the radial muscles here compared to here? Here is in a contracted state, right? Okay, so these radial muscles here are in a contracted state. I should. Here, in this state, it is in a relaxed state. You can see it, right? When muscles relax, they should be longer. So the radial muscles, if I were to compare here to here, okay, here is relaxed. They are much longer. I like to think of radial muscles as, have you ever seen those curtains, those blinds, where you pull then it kind of pulls up all the blinds up. You remember, have you seen this before? Like that. Then after that, got one string, right? Then you go and pull, then everything goes up, right? Yeah. I like to think of radial muscles something like that. That is kind of their role. To kind of pull back the circular muscle fibers, or to let the circular muscle fibers come in. Okay, so now I'll just use pure logic. If there is a lot of sun, there's a lot of light coming into your eyeballs, which one would you want to adopt? Right, to protect your inside of your eyeball. Right? Can I? The logic can I? Okay, this one logic still okay lah. So if there's sun, you want to adopt this. Right? Circular muscles contract, radial muscles relax. When it's not so bright, then you can adopt this one. Okay, using pure logic here. Okay, so here's the sun. Then this one will be nighttime. After nighttime doesn't mean nighttime only. If I switch off the lights of this classroom, you also see your pupils enlarging. Okay, this right in the middle is your pupil size. Pupil. So you can also see that the pupil size will shrink when it's too bright, pupil size are big when it's too dim. I find this part of the chapter still okay because it's very relatable. Something too bright, naturally common sense will say that it needs to shrink the pupil size. This is still okay. Okay, the next part we're going to go into is talking about distance. I want to show you my own pupil reflex. This is my own eyeball. Much nicer looking, right? My current eyeball. You see it doesn't look nice. Okay, so this is my own eyeball. This is the reflex action, by the way. Okay, how is our eye able to do it by itself? It's by reflex. You don't have to think about it. I want to show you my own eyeball. I show you my own pupil size changing. When from darkness, I suddenly switch on the light. Okay, see again. So, it is currently very dark. And then this is what I did. I shined my iPhone torchlight right in my eye. Okay, then it really, this was quite painful. It took 10 tries. Very fast, right? Okay, let's take things one step further. Just now, we call this a pupil reflex, right? Now let's relate this back to reflex arc. With every reflex arc, you need something to be able to sense the change in light. And then you need to have an effector to adapt to the change in light. Do you know where the sensory neurons are? Okay, your photoreceptors. So your photoreceptors at the back of your eyeball, that's what detects the change in the amount of light. Can you tell me what the effector is to respond to the change in light? The muscles. The muscles. The iris muscles, which are the circular or radial muscles. Yeah? So I want to show you that actually even when you talk about this, there's a reflex arch. There's something that senses the change. There's something that will affect the change. To respond to the change. And your circular or radial muscles is the thing that will change in response to the change in light. Still okay? Okay, now the next part of our lesson, let's talk about distance. As a student, I found the distance part a little bit more challenging. Okay, there are several layers to understand when you want to understand how our eye works when looking at things far and near. If the iris is important for brightness, then distance, what's important is your lens, ciliary muscles, and suspensory ligament. Okay, I'd like to show you where they are. They can be found behind your iris muscles. So let's look over here. From this perspective is nice. Okay. So you see this ring of muscles over here? These are ciliary muscles. Then you see these fiber-like things? These are suspensory ligaments. They are nothing more like strings. These strings are attached to something in the middle, known as a lens. Okay, look at this. You see a transparent thing over here? I'm going to color it. Okay, this is the lens. Anyone eat fish before? They like to eat the eyeball? Okay, inside the eyeball, sometimes you find one transparent ball thing. That's the lens. Okay? Hey, do you dissect eyeball in your J3? No. Okay, eyeball dissection. Okay. Okay, this video is very good. Now, I want to show you the parts of the eyeball since you've never seen it before in real life. Okay, this dude, right? You don't follow this dude because he doesn't even wear gloves when he dissect. Okay, so okay, what is this dude is holding a cow's eyeball? I mainly want to show you this so that you can see the lens. Okay? Okay, so as we tear apart this eyeball, you start to see the important parts. Okay, sclera. Yeah, okay, please don't be like him, huh? I don't know why he's not wearing gloves. Okay, okay, very good. What he's holding there, these are the iris muscles. You see one hole right in the middle? That's the pupil. Okay? Alright, I want to show you the lens. The lens is this thing over here. The lens is like a little sack of fluid. Look at what it's holding. That is the lens. Okay, of the eyeball. You also have that. Okay? Notice that it has been cut upside down. Okay, so what is the lens purpose for? The purpose of the lens is purely to refract light. You all know in physics refraction? Those who take physics. I think lower J also you learn refraction. Refraction just means bending. Okay? The purpose of the lens is just to bend light. I want to show you how our lenses are able to bend light. Okay. You have a newspaper. Anything you want to burn? Money? To appreciate how our lens work, okay, I brought two lenses from the lab. Here I have one lens that has been not so stretched out. Okay, maybe it will make more sense if I compare it to this one over here. Look at this lens over here, flatter, stretched out. Right? This lens over here, not as stretched out, more like fatter, right? Okay. Let's look at what happens. What's the difference between a lens that's not so stretched out and one that is more shorter and compressed? Okay, but I need to burn paper first. You have a newspaper? Where's my lighter? Okay, there it is. Let me just burn stuff. Don't mind me. Oh, your newspaper? Let me just burn because I need to create a smoke chamber. Then we can appreciate how our lens work a little bit more. Oh, you have some paper? Oh, tissue paper also can. Oh, okay, very good. Let me burn some tissue paper. Yeah, I'm just creating a smoke chamber so we can appreciate lenses a little bit more. Okay, but you may smell a lot of smoke now. You just bear a bit more. Yeah, just run out of fire. Oh, really? I ran out of fire. Oh, well, I don't want to say. Oh, okay. Yeah, let me switch on the fan for a while. If it doesn't work, then I'm going to move on, I say. Oh, I don't want to waste your time also. Unless someone brings lighter to start. I really not waste your time. No, no. Shit, I think I have to get up too much. Why is my lighter not working? I think I ran out of gas. I think I really ran out of gas. Okay, wait. Burning. Okay, if I really cannot get to work, I need to move on. That's so far away. I think I really have to. I can only get a spark, not getting a fire. Okay, I don't think I can really get a fire unless you don't mind waiting for a while I go to the lab. But I really don't want to waste your time, sir. Right. Okay, I can do it after. I'll just talk about it first. Okay, so later I can really show it at work. Okay, later on, right, what you'll see is this. Okay, I've shown you two kinds of lenses. One lens is very fat, then one lens is very thin. Yeah? Okay? Okay, so just remember this. The fatter the lens, the more it bends light. Okay? The fatter the lens, the more it bends light. So, when light is traveling through a very fat lens, it will end up bending the light a lot more compared to a lens that is much thinner. Okay? You observe that there is an intersection point. Okay, when light bends. Okay, when light bends, it will bend towards an intersection point. Okay, and we refer to this intersection point as a focal point. And this distance over here is a focal length. So when you have a lens that is thick, it will bend light more. When you have lens that is thin, it will bend light less. The challenge for us really is that we need this focal point to land on the back of our eyeballs properly. So, for example, if I have an eyeball like that, I need the light that is coming in to bend such that it's just nice landing at the back of my eyeball. That's the purpose of what our lens is supposed to do. It needs to bend light such that it concentrates to where the back of the eyeball is. So now comes down to, when do we use a lens that is thick? When do we use a lens that is thin? Can you still remember? I'm not sure if you do. This boils down also to what is the nature of light that is coming in from far away and the nature of light that's coming in here, that's coming from very, very nearby. Okay, so let me just change this up. So let's say this is the back of the eyeball, this is the back of the eyeball. Light that's coming in from very far away tends to be very parallel in nature. Okay? So we're going to draw light rays coming in. Light rays that's coming very far away tends to be very parallel in nature. Okay? The problem is that when we use a very thick lens, it will bend light too much, such that it won't land at the back of your eyeball. But a thin lens bends light not that much. So it can result in the light bending to touch the back of the eyeballs just nice. This is for things that are coming in from far away, an object that's really far away. However, if you're looking at something really close, okay, let me just use the same lens over here, okay, and a thin lens over here, okay, then the back of the eyeball. When looking at things really, really nearby, let's say the object is right over here. The light rays that's coming towards you is diverging. Okay? And if the object is really far away, right, it is not diverging as much. Okay? So an object that's really close, nearby, the light rays for it to enter the eyeball actually is spreading out. Okay, it's actually spreading out. But here's the problem. When we have light rays coming in that's spreading out and we use a thin lens, we won't be able to bend it enough to land on the back of the eyeball. It doesn't bend it enough. Instead, we need something that's a little bit more power. We need a lens that's thicker, that's able to bend light more. So light that is diverging and it's very near us, we need to let it bend. We need a lens that's more powerful to bend it more. Then it will touch the back of our eyeballs nicely. Okay. So what's the point of all this? When you're looking at things far away, okay, so this is for near, and this is for far. When you're looking at something far away, you will need a lens that's thinner, because you don't need to bend light as much. When you're looking at something near you, you need a thicker lens to bend light more, so that it can land, the light rays can focus on the back of the eye. So that's the logic that we will apply here first. Okay? So when you're looking at something near, when you're looking at something far. Still following? Good job. Okay, then I'll just introduce one final step up. Okay, and then if you cannot remember, then just remember this all. When you're looking at something far, your lens also need to be long. Okay? When you're looking at something nearby, your lens also need to be shorter. Yeah, so there is a shortcut way if you don't want to, if you feel like you don't understand what is happening. Okay? Okay, so one last final step. If you look at where the lens is, the lens, if I look from the front view, let me erase this whiteboard. Front view, side view. The front view, if you look at your lens, it looks like a circle. From a side view, it looks like this. Okay? Your lens actually is not just there by itself. It is held together by these things called suspensory ligaments. They are like strings. They are not muscle. They are more like strings. From the side view, it looks like this. Okay? Next, there are ciliary muscles. Ciliary muscles are muscles that are circular in nature, like your circular muscles. Okay? Ciliary muscles are muscles that are circular in nature. They run in this direction. So from the side view, they look like this. Often you will see us draw it like two circles, and then we put dot, 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 dot. Because when we cut the muscles from this point of view, you end up seeing the fibers looking like dots from this perspective. Okay? This is what it looks like when the lens is thick. A thick lens. Oops, a thick lens. This is what it looks like when the lens is thin. Okay, when the lens is thinner, you'll notice that, let me erase this more. Watch what happens when the ciliary muscles relax. Okay, this is in a contracted state. Can you tell me, when ciliary muscles relax, do you expect the ring to open up or to be smaller? Okay, these circular muscles, when they relax, will the ring become bigger or smaller? Bigger. Okay? So you look at these circular muscles, if they relax, they lengthen. So overall, they should open up. Right? Okay, so let's open this up. Okay? If you relax, you open up, right? Okay. And the thing is, when it opens up, all these suspensory ligaments that are attached, they will become very tight. They are like fishing lines from the edges, pulling on the edges of the lens. And you know what happened to the lens? The lens will be pulled. Okay, the lens, in a sense, they are being pulled outwards. When this ciliary muscles relax. This is what it looks like from the front view. But from the side view, look, it ends up looking like this. From the side views, here is the ciliary muscles. If I match it at the side, here's the ciliary muscles. The suspensory ligament has become tighter, and you find that the lens has become longer also, because they're being pulled when it relaxes.